right? So, y sub 1, I have the point and I have the slope, right? X sub 1, y sub 1, the m. So, y minus y sub 1, the y sub 1 is 3, like that. And then, m is 3, just above. Then x sub 1 is 4, right? So, simplifying this one, distribute the 3. 3 times x, I'll have 3x. 3 times negative 4, I'll have negative 12. Okay. Writing the slope-intercept formula, I'll have y is equal to 3x minus 12 plus 3. Or y is equal to 3x minus 9. You may write the standard equation of a line there. It will serve a purpose later. But for the meantime, I use the slope-intercept format. We are not yet done. What I have now are just the equations of this and this. If I'm gonna solve those lines using substitution or elimination method, then I'll arrive at its center, the intersection point. Now to do that, excuse me, sorry for that. To find the center, the intersection point, solve the equation using elimination method. Alright. Elimination method is best used when it's in standard format. But if it's in slope-intercept format, it's also fine. But here, so I have transposed the negative 2x to the left side. So it turned to be 2x plus y is equal to negative 4. Then 3x to the left side, it then became negative 3x plus y is equal to negative 9. I left negative the 3 there to be negative. It's fine in elimination method, but if it's in standard format, it is not allowed to be negative. Alright, so elimination method, what's the requirement? There should be a term to be eliminated, and I think that is y. The variable y can be eliminated by subtraction, y minus y. Alright, that means to say I need to subtract the two equations, all of them. So step 1, using elimination method, right? See the symbol, I need to subtract all of them. So 2x minus negative 3x, I'll have positive 5x. So y minus y, that is eliminated. Cancelled. Out of story. Now, negative 4 minus negative 9, it will be, I can use KCC. Negative 4 minus minus 9 will become negative 4 plus 9. So, negative 4 plus 9 is positive 5. And then solving for x, I need to leave x alone. So, I need to divide both sides by 5. Cancel, cancel. Because that is equal to 1. 5 over 5, do not cancel it. That is equal to 1. And I have the x coordinate of my center. What's missing is its y coordinate. So step 2 in elimination method, I can substitute to any of the equations present above. I may choose this one, this one, this one, or this one, any of them. Now in this case, I have used this one, equation 2. I will substitute the value of x there, evaluate, then I'll receive a value of y. Something like this. So y is equal to 3x minus 9. Plug in 1 to x. Then 3 times 1 is 3 minus 9 is equal to negative 6. Then the center is at 1, negative 6. Quadrant. What is that? Quadrant. Quadrant 4. Let us review the figure. Is it really at quadrant 4? Is the center at quadrant 4? 1, negative 6. Actually, correct. Alright. So, next. To find the radius. Why do we need to use the radius? Because in the problem, you are asked to find the standard equation of circle. To do that, you must have center and radius. So here, I'm gonna use a distance formula between the center 1 and negative 6 to any point A, B, or C. If you recall the picture. Okay? So, yeah, pasilip. Yun. Okay? So, if this one is the center, just choose any of the point A, B, and C to identify the radius. Okay? In that case, I used B. So, distance formula, there is a square root in the formula. Okay? The changes in the x coordinates, the y coordinates, both should be squared. Then, add their sums, take the square root. Okay, so x coordinates 1 minus 1, y coordinates 4 minus negative 6, like this. 1 minus 1 is 0. 4 minus 6, KCC. It will become 0 here, ito, 10. 0 squared plus 10 squared is equal to 0 plus 100, or the square root of 100, okay, which is equal to 10. Alright, we have the radius, we have the center. We can now write the standard equation of the circle. At HK, 1 is the H, negative 6 is the K, okay, then R is 10. So using this one, plug in H. So 1, x minus h will become x minus 1. K is negative 6. Y minus k will become y minus negative 6. Okay, R is 10. Okay, so quantity of x minus 1 squared plus the quantity of y plus 6 from KCC squared is equal to 10 squared. Just simplify the right hand side. Then this one is the original or the standard equation of the circle of the broken plate mentioned by the archaeologists. Alright, so here the original h should be positive 1, original k should be positive negative 6, and then the radius should be the square root of 110.